y'all, it's Dr. Know-It-All. So that was a monster presentation. Tesla's Investor Day was over 3 hours long, so it was pretty crazy. So what I'm going to try to do here tonight is to give you a kind of a speed run through everything that I felt was important throughout the entire Investor Day. I have some very quick notes I jotted down. I am not going to edit this, so there will be mistakes. There will be things that are wrong. I apologize about that. And I'm going to sort of begin with a TLDR in case you just want the big picture stuff and what Tesla didn't talk about and the reason why, you know, not a financial analyst, but my prediction is that the stock price will go down tomorrow. So again, don't assume that I am correct about that, but that is my guess about that. Anyway, I want to begin with something that Rob Maurer posted prior to the Investor Day presentation, which was super cool. Very jealous that he got in. And that is pictures of the Cybertruck. So this, you know, everybody knows that the Cybertruck has hardware 4 on it. And so we can see here that it's pretty clear in this image, and it looked like there were 3 cameras previously, but it looks like they do still have the 3 cameras in the top part, which was debated. But here's the interesting part, and this is something we did not see in the other vehicles, and I had speculated that maybe the Cybertruck would be the first vehicle with front bumper cameras, and look at this. So as he was going around, that certainly looks like front bumper camera material here, right? So he didn't show a lot of the other stuff, so I couldn't tell if there was 3 of them. This would be on the more right-hand side of the vehicle, so there could be 3 or maybe 2 spaced across. It's a little difficult to tell, but that certainly looks like a camera there. And then one other really interesting thing is there is a kind of a, not square, a soft rectangular thing, whatever you want to call that. But anyway, so the steering wheel is not a yoke and it's not a traditional steering wheel. It's an in-between. And maybe Tesla has decided that that's a good form factor because again, you know, if you're not going to be doing drive-by-wire and stuff like that, and so you have to turn the wheel multiple times around when you're going slowly, it'll be more comfortable to be able to do it like this rather than the way the yoke works. And one final little thing up here is that we can definitely see a pillar camera right there. So there's definitely a pillar camera. So it looks like the pillar cameras and it looks like the 3 front cameras, that kind of stuff is the same, but that the Cybertruck will have an additional couple of cameras. This makes really good sense for something like a truck where you could be doing off-roading and going very, very close. You know, when you're loading and unloading materials and things like that, you need to get very, very close to like a house or potentially over something. Or if you're going over rocks, you want to be able to see that. So it makes a lot of sense that they would put more cameras on that. They're going to be a pain in the butt to clean. I can't even imagine. But anyway, so that seems like a giant pain in the rear to me, but you know, whatever. Okay, anyway, continuing on, here is part of the preview thing that was going on during the Investor Day presentation. And let me just shut this other thing down here. So anyway, you can see that this is the same thing that they had on their Investor Day thing, which is just a ton of side bodies. Unfortunately, we didn't really get much else. So what did they not talk about and why are investors in general probably going to, at least institutional ones, going to be a little less than super impressed? Well, they didn't talk about a new car, although they teased the heck out of the next gen vehicle. They never did reveal it. I kind of thought that Elon was going to do a one more thing like Steve Jobs and actually reveal it at the end, but no. They didn't talk about the new factory, which is really fascinating since the president of Mexico just yesterday or today actually talked about the new factory in Monterrey, in that area, Santa Catarina. Anyway, so they didn't tell you about the new factory, although they did again tease that there will be a new factory. And they didn't directly talk about hardware 4, although Ashok Eluswamy actually got to get up and talk about autonomy, which was great. Unfortunately, a lot of the autonomy stuff was pretty much what we'd seen at AI Day 2022, so there wasn't a lot of new information with there. One thing that we did get some new information about, however, was Optimus, so that is very cool. So anyway, let's go through. I'm going to kind of walk through the presentation. I took screen grabs as I was going, so again, forgive me if they're not all perfect, but hopefully we will get what we got. Yeah, so we've got... they start off with a problem statement. This is a good way to begin. And they basically said that they were going to break this whole thing, the presentation, into 3 parts. Number 1 was the macro. Number 2 is Tesla, and number 3 is impact. So basically they started with the macro, and they're talking about the problem of converting the Earth to sustainable energy, 100% sustainable energy. And that's Elon Musk and Drew Baglino were the people who did the presentation for this. So Elon went up and talked about Master Plan Part 3. They did not present like a a blog post or whatever, but Elon did say there would be a white paper about this. So probably, if that's not already out, it will come out shortly and it will be on Tesla's website. So anyway, only a third of global energy delivers useful work. That's actually a really, really important thing about fossil fuels that is important to understand. Most of it is heat. It's wasted energy. So anyway, and 80% currently of global energy currently comes from fossil fuels. So what do you need for a sustainable future is that you need to get this sustainable energy up to about 82 petawatt hours per year. So it's a lot, but they talked a lot about how electrical renewable energy sources are much more efficient than these other traditional fossil fuel sources, so that this isn't as bad as you might think. So anyway, he wants, as Elon Musk had teased before, this was for all investors of Earth, for all 8 billion people, that Tesla wants to create a clear path to a sustainable Earth with abundance for all 8 billion people. And again, they do have the math here, so it's not just a pie in the sky kind of thing, which is very, very cool. Okay, so anyway, as this shows, electrified energy can use half as much energy as fossil fuel economy because it's such a more efficient type of generation of power. So the first thing we need is massive energy storage, 240 terawatt hours. We need 30 terawatts of renewable power manufacture, $10 trillion of manufacturing investment, and half the energy required, again, of fossil fuel. So it doesn't have to be a one-to-one match. And they do say, Elon said, that it's only 0.2% of the land area that's required and it's less than farming. I guess farming is about 12% of the land mass of the globe. And so this is much, much smaller than the land mass required for farming to be able to create 100% sustainable energy. It's 10% of the world GDP for 1 year, but as he said, if you split it across 10 years, it's 1% per year. If you split it across 20, it's 0.05% per year. And he says there are 0 insurmountable resource challenges, which is pretty amazing. So, okay. So anyway, so there we go. Yep. Anyway, oh yeah. And this was an interesting thing. I don't know that this is true, but I think it is actually. I haven't done the calculation in my head, but Elon Musk said that we get about 1 gigawatt per kilometer squared of sun energy. And I think that scales up right, because I always think about it in terms of 1 meter. But that means that one square kilometer of land mass, if you cover that, well, if you just absorb all of the energies, all of the energy from the sun, you get 1 gigawatt for that. So it's a pretty amazing amount of energy that's here for the taking if we can just manufacture things that are efficient and can work in areas where people don't really want to live anyway, stuff like that, right? So basically, he was saying that between that and wind and some, geothermal and other things like that, you would only need a small land area to become fully sustainable. And the resources are available, and that mining would take less than the current economy's mining. So that's also very important. So here we have renewable power, switch to electric vehicles. This is sort of the way, the path forward. And honestly, this is in terms of the stuff that you want to probably listen to, if you don't want to listen to the whole thing, this first part is the most important, sort of master plan part 3, where they talk through these elements. So it's really interesting. Renewable power to the existing grid, obviously important. Switch to EVs, and then these next ones are where it gets really interesting. Switch to heat pumps, which having gone from being a kid, and I grew up in Cleveland, Ohio, we used a gas furnace to heat ourselves. I think at one point we had an oil one when I was very young. But anyway, we went from that to where I live now. We have a heat pump, and the heat pump is so much more efficient than gas for actually creating or for extracting heat out of the environment, not creating heat. That's the reason why it's so efficient. So anyway, switching to heat pumps, 29 petawatt hours per year is pretty insane. And then we have high temperature heat delivery and hydrogen, which is also very important. So that actually has to do with manufacturing, not with driving, just to be very, very clear. And then we have sustainable fuel, planes and boats, things like that. So that's actually making large things like, mass transit, like boats and airplanes that people don't think can be powered electronically, done as much with electronics, EV, battery type of production as possible. Okay, so here we go. We get into this now. We need 24 terawatt hours of stationary battery storage, 10 terawatts of solar and wind power, and the manufacturing cost will be somewhere around $800 billion. So but the cool thing up here is you get a 35% reduction in the fossil fuel use and full sustainability. So those are pretty impressive figures. Then we can move on to vehicles. So switching to electric vehicles, you get a 21% reduction in fossil fuel. And let's see if I can find the numbers here. Sorry. So if it's we have currently 10% market share for EVs in 2022, which is really remarkable. But one thing is, of course, EV cars, and the other one is autonomous, which is the reason why we eventually get to autonomy eventually. But what we'll get is the 2 billion cars and trucks are on the road today, but the plan is to reduce that to 1.4 billion cars, which is a smaller fleet because we will utilize cars in a more efficient manner if we're doing things with autonomy. And so everybody doesn't have to have a car that mostly just sits in the garage and doesn't do anything. And so they're saying they're going to need everybody together, not just Tesla, is going to need to produce 85 million cars per year, and that will convert the world to electric vehicles. Tesla is still very much on board with 20 million vehicles a year themselves, although they didn't put an exact timeline on that. So anyway, this was a fascinating thing. Let me see if I can find this slide. Hopefully, oh no, interesting. This is interesting. Somebody, I think it was Tesla Scope, pointed this out. They believe that this would be a small car, the Model 2 kind of thing like that. This looks like a van. Could be a robotaxi van, could be a delivery van, could just be a van shape. So anyway, they have actually added in an extra category here that we didn't have before. So that's very cool. But you can see the number of vehicles of each category being produced. But 700 million of these small-sized vehicles, all the way down to 20 million semi-trucks. But this is the sort of mix that they're looking at to be able to make this all work. Okay. Oh, here it is. Okay. So because the wheel-to-well efficiency of a Corolla is so low, it's only around, I think, 25%. I think that's what he said, somewhere around that. Yeah, anyway, it's 4 times more efficient wheel to well to drive a Tesla Model 3 than it is to drive a Toyota Corolla. And a Toyota Corolla is an inexpensive, mass market, relatively high mileage car. So it's pretty remarkable what having batteries does versus burning stuff in an engine. And remember, you have to mine this, you have to get it out of the ground, you have to refine it, which all takes a ton of energy. You then have to transport it, you then have to put it in the car, and then when you put it in the car, it's only like 33% efficient at driving you forward. Most of that goes into heat. Now, batteries do produce a lot of heat as well, but they're much more like 85 or 90%. I think wheel to well, they're around 85%. So, you're looking at about 4x more efficiency than a Corolla. So that is a pretty impressive thing, and it really drives home the point of why we can transition to a sustainable energy economy without, breaking the environmental or laws of physics bank or something along those lines. Okay, next up we have heat pumps. So this, like I said, is very interesting. He said that Drew Baglino, I believe, was talking about it at this point. He said it's only $300 billion manufacturing investment to create, heat pumps. And this actually will reduce the amount of energy that's needed because you don't need as much fossil fuel if you're driving heat pumps. Also, heat pumps can be solar or wind powered, so they can be powered by renewable sources as opposed to something like gas, which has to be fossil fuel because it's gas. You're burning something. So this is really interesting. Heat pump is a very impressive thing. They said 3 times reduction in heat requirements and heat energy requirements. It's in our cars already. I mean, we already have heat pumps in our Teslas. And so, hopefully we will see heat pumps for the home soon. It's also possible that Tesla's just throwing this out there for somebody else to do. This is the kind of thing where if you're a company that could potentially manufacture something like this, why not go for it? Why not just go crazy and start building heat pumps that are mass manufacturable as opposed to the ones that exist right now? So lower cost, easier to build, more mass manufacturable. So anyway, It's a really, really cool thing. I'm very happy to see him talking about heat pumps again. Elon Musk has talked about that before. All right, next up, yeah, heat pumps, they move heat. Yeah, we got that. Then we get to, electrify high temperature heat delivery and hydrogen. And so hydrogen is important for industrial purposes. It's currently very dirty. It's natural gas reforming is, I believe, what it's called when you make it. And that's actually taking natural gas and pulling hydrogen out of it. So you're mining natural gas and then you're applying a massive amount of heat to it to extract hydrogen. So that's all just ridiculously bad for the environment, very energy inefficient. And then to be able to do this, you have to be able to create a way of taking energy and turning it into extremely high, voltage slash amperage energy to be able to utilize it in these industrial applications that needs a lot of heat to be able to manufacture things. I mean, if you're going to make stuff, you need to be able to have this kind of thing work. To transfer this from the fossil fuel industry to sustainable, renewable energy is a big deal. It's going to be, challenging as well to do this. Just again to point this out, this is not going to be used for driving cars. It's not a Nikola semi truck that supposedly will be running on hydrogen. They're just talking about this for industrial purposes. So anyway, this is like they say at the end that there's no showstoppers. This seems to me honestly like the two last ones seem like the most difficult. This one, and then if we get down to the next one, which is boats and planes, because that requires a huge amount of energy density in the batteries. But what's interesting is that Elon Musk talked about how what you need to do is change the architecture of these vehicles. You need to not, this was a good dig at a legacy auto. He said that basically you can't just take a battery and dump it in the place where the engine used to be for a gas car. That's not how you do it. You manufacture it, you build it, you design it from the ground up to be an electric vehicle. So you don't just take a boat, you don't take a ship and just plop batteries in it. What you do is you redesign it from the ground up. Same thing for an airplane, things like that. He predicted that short haul aviation could actually be disrupted by electric vehicles relatively soon. And you can see a lot of people developing vehicles in that sort of vein right now. But that long haul would be more challenging, and of course boats and things like that as well. So anyway, apparently in order to do short haul flights, you need around 450 watt hours per kilogram efficiency, which there are cases of lab designed cells that are working at that efficiency, but they're not mass manufacturable yet. So anyway, lots and lots of really cool stuff. All right, so next up, we have sort of what we need to be able to make this happen. So we need 30 terawatts of solar and wind farms to be able to generate the energy. We need 240 terawatts, which can come from vehicles and stationary batteries. This is interesting. They kind of let this go. But, my prediction was that they were going to talk about how they were going to be able to hook vehicles up to the grid. Now, supposedly the Cybertruck and I'm sure the next gen vehicle and the robotaxi, etc., will be able to power the grid as well. So if they're not being utilized, they can be plugged in and they can backfill, so they can charge up when electricity is plentiful and cheap. They can sell it back or use it for an individual person's house or something when it's expensive, et cetera, et cetera. And then manufacturing capex and things like that is somewhere around $10 trillion to be able to make this all happen. So, yeah, so here we go. So we just need 3x solar and wind deployment by the year 2030, which actually seems pretty reasonable. That's the kind of development that just seems to be happening at the scale like that already. EV production needs to go up by 11x. That is a bigger ask. And then vehicle stationary and thermal battery production in terawatt hours per year, that needs to go up by 29x. So you can see in terms of development of sustainable energy production sources, that's actually the low-hanging fruit. The other ones get progressively more difficult, but they were very confident that this would be workable by 2030 or thereabouts. So here you go. So, and again, this is an important point. A sustainable energy economy is 60% the cost of continuing fossil fuel investments. So currently, this is 20 years of investment in fossil fuels at the 2022 rate. So, inflation adjusted $14 trillion. So that's, what is that? 1.4, 700 billion dollars in investment per year. And what they're saying is in 20 years, if you did this out to 2043, it's only going to cost $10 trillion. So it will actually cost substantially less than the amount of money that we put in every year into just keeping the fossil fuel industry operating. So that's a pretty important slide there as well. So, and then also, of course, we have, solar direct land area, and they just sort of point out how small these areas can be. Wind, and then total earth land area. So basically, they're just pointing out that you need just tiny amounts of space to be able to create this kind of power. Now, again, because of distribution issues, you're probably going to want to spread this out more than this, but it's just kind of an example to just show how this works. And like I said, the idea here is that it's an order of magnitude. It's like a tenth the size of the land that we need to farm to be able to feed everybody. So that's a pretty big deal as well. And then what's really interesting here is that a lot of people talk about mining and how this is going to be so terrible. But if we go from this slide to this slide, I need to blow these guys up. If you go from this slide to this slide, you can see that it actually uses less amount of mining, less amount of materials, things like that, than what we're doing right now to drive the economy. So that's actually a huge point as well. So yeah, so anyway, all of this stuff just kind of means that this is actually possible, right? The resources are there. You've got nickel, you've got lithium, you've got zinc, you've got, this is an interesting slide, is that this is what people think happens. Like, you mine a certain amount of lithium and it sort of disappears and eventually it runs out. But what actually happens is that you discover more stuff as you start looking for it. So nickel is our, this is lithium. So you can see that lithium in particular, the discovery of the amount of lithium that's around and available to extract has gone up from about, a 1x to about 8x. So it's increased drastically in the last 20 years. So it's kind of opposite of what you think. It's sort of like the harder you look, the more stuff you find. So anyway, that's a really, really interesting thing. And Elon said that the United States has enough lithium on its own to electrify the entire globe. So that's not that that's what we should do, but he's just saying, as an example, just the country of the United States has enough lithium to electrify the entire world. And the limiting factor is actually refining into battery grade lithium hydroxide. It's not actually finding it because it's kind of available everywhere. And then, of course, we get to the recycling stage of this in the future, which is that eventually the need for mining is going to go down significantly because most, let's say 80+% of the minerals and things like that we need will just be in the system already. And so you break down batteries and other things like that, and you get back these minerals that you need to be able to produce the new ones. So you don't have to go out and mine this stuff as well. So anyway, Elon did mention that the heavy lifting for electrification is going to be LFP, or lithium iron phosphate batteries. Iron is the most common element on the earth. So, that probably was fairly obvious to most of us who've been paying attention, is that LFP is the way to go. It's getting much better, but that means that only for like high performance batteries for things like airplanes and boats eventually. Currently, of course, more high performance car type vehicles will also use them, semi-trucks, things like that. So, but eventually most cars are going to use LFP batteries because they're becoming very, very viable, and they involve much, much more available materials. So that's all good. All right, and here we go. This is what we need to do. So again, we're back to this original slide, which is that this is how we do it. This is actually master plan part 3, is just get to all of these things. 240 terawatt hours of storage, 30 terawatts of renewable power, invest $10 trillion of manufacturing, and put in the other things that are needed. So yeah, pretty cool. So, all right, so let's see now. Okay, so now we get to Tesla's contribution. So we get into, Lars and Franz were the first two that actually did the presentation. And they started off obviously with designing, cars from the get-go. We have the production hell originally. And we need to be able to scale smaller and more efficient, but still great design and engineering and manufacturing at the same time. So they talked about how what they did at the beginning was they designed and then they engineered, and then they manufactured. They said at the beginning with the Model S, they didn't even have a factory at the time they were designing it. So they couldn't do the engineering and the manufacturing at the same time. So anyway, this process has evolved. And what they really want to do now is design, engineering, manufacturing of not just the vehicle, but also the factory all at the same time. And then automated manufacturing. This is where the production hell came in, because this was an interesting insight from Franz, was that what they'd done is they designed the Model 3 to be built by hand, and then they decided to automate it. And he was like, the problem was we designed the car the wrong way. We designed it for humans to build, and then we tried to automate it, and that led to production hell. And it was like a huge mistake. So what they're learning, and what they've got with their next vehicle, which is the Cybertruck, which we do know about, is that will be designed, and they had really, really excellent, amazing graphics of putting these cars together in a better way, but it's going to be designed to be automatically manufactured, not built by hand, kind of. So that's more like the way it goes. So anyway, so, Cybertruck manufacturing first, start with the steel and design from there out. You can't stamp the panels, so you have to make it very planar and linear. And it's a super dynamic design, which is really interesting to think about because it kind of looks very blocky and stationary, but I love the idea that it's a super dynamic design. Then you have to rethink the factory footprint. No stamping, no heating because it's cold rolled steel, smaller factory. It is coming out this year. They reiterated that that's going to be the thing, and that the teams are integrated. The way that this has been designed is to integrate the teams, all of the teams, including the factory team from the get-go, so that everybody's thinking about how to build the alien dreadnought that builds the machine at the same time that you're talking about the machine itself and how that's going to look. So that's very, very cool. Yeah, so here we go. So you put all these things together. The current way of assembling a vehicle is currently you do stamp, body, paint, final assembly, and it's a very complicated mechanism, and they get into some really interesting slides. And again, if you want to watch the video itself, this is animated at this point, but what happens is you sort of essentially put the vehicle together, you paint it, you take it back apart again, you put a bunch of pieces in, and then you put them all back together again. It's a crazy, crazy inefficient way of building something. And so the goal is for them to build it, instead of building the entire vehicle at once, you want to build it in this sort of more modular fashion. So every piece of the car is constructed on its own and painted and whatever else you need to do with it. And you can see that there's a space efficiency here, right? So there's a 44% operator density increase. You can fit 4 people much more efficiently around a small thing. And there's a 30% space-time efficiency increase. And then what you do is you test out all of these individual parts one at a time, make sure that all the subcomponents are working. And so you don't have, and this is going to get into some software like cabling things later on, but after you do all those individually, you just go and you put them together once. And that's the kind of deal where you can be much, much more efficient in building your vehicle. So, yeah, so here we go. So, right, now what you're getting is parallel and serial. So you're building all of these parts simultaneously and then feeding them together at the end to build the actual vehicle itself. So that's very, very cool stuff. Super interesting. Again, here what you've got is you've got all of these pieces that are happening simultaneously, and it puts the entire thing together in one go with all of the sub-assemblies tested previously. So much more efficient for people or robots. The operator density goes up. It's parallel and series manufacturing. And you're building the parts independently. You're painting only once needed. You put the car together only once. And so, and obviously this is the body side, I think, that we were seeing in the introduction in the Investor Day invitation. Losing my voice. All right. And then what we get is the next generation vehicle manufacturing. The footprint of this would be the factory itself, the legacy footprint. You can see how you need a smaller footprint. There's a reduction in cost. There's a huge amount of efficiencies gained by creating a car this way as opposed to the traditional way of building a car. So again, first principles, don't do it the way everybody else has done it. Do it a new way and a better way. So again, relentless focus on efficiency. So this is very, very cool that the Model Y is that much more efficient. So yeah, so anyway, at this point they said that they are, unfortunately not going to tell us about the Gen 2, Gen 3 car, whatever it is. So we will not find out about that at this presentation. Sorry. I did tell you at the beginning, so you didn't have to watch the whole thing. Okay, so again, efficiency helps us scale. This is, I believe, yes. So this is going from the original design of the Model 3 to right now, not even talking about Project Highland, which we also didn't hear about, but 20% lighter drive unit, 25% less rare earth minerals, 75% smaller powertrain, 65% cheaper powertrain. So tons and tons of stuff. And I believe that they were talking about, if I'm not mistaken, that they are going to use no rare earths in the new powertrain. I think we're going to get to that. So that's really cool in its own right too. Okay. So some stuff about, I'm going to kind of speed through this a little bit more because this gets, kind of into the weeds, and you can pause this if you want or go watch the video. But basically they talk about integration, vertical integration, building things themselves. They can do what they need to do. And yeah, here we get into the powertrains. So we get, they can use their own in-house simulation software to design these powertrains, which is really cool. Wish I had access to that simulation software. That's got to be amazing. This is the magnetic fields inside the motor. So they can build a better and a better motor, and they can utilize this across different vehicles. So it's not just a one-off. They can actually leverage this and use it. And later on, they talk about how they used the same team to design Optimus's actuators that build these motors. So they can, again, leverage it even out into humanoid type robots. So again, line automation. We've got, unfortunately, right? They don't show us what this thing is. I hate this by now. I hate this graphic. They just keep showing it. But a 75% reduction in silicon carbide. Any battery chemistry will work with it. So it's battery chemistry agnostic, and 50% reduction in, I think it's rare earth, sorry, there's 50% reduction in factory footprint. I believe that's what it is. And it only costs $1,000 all in to build this drive unit. So it's just a massive reduction in the amount of effort and scale and cost and everything that goes into this. So this is just amazing. Oh, here it is. Yeah, so the idea is going to be that there's very little rare earth elements required for the Model Y, but that there will be no rare earth elements in the next drive units. They will use permanent magnets, and that's going to be amazing. So clearly they're going to look at a more efficient, probably less performance-oriented, if they're using no rare earth minerals and they're using a permanent magnet, the performance of that is not going to be on par with the Model S Plaid, obviously. But again, we're looking at a whole different type of vehicle. So anyway, it's going to be a pretty amazing thing, and they're going to be able to build it in half the size, which is just amazing. And they'll be able to use less constrained commodities, because don't forget, the rare earth minerals and stuff is not just costly, it's also constrained. It's difficult to get these, and you could run out, and if there's problems in parts of the world and stuff, there could be supply chain issues. So a lot of this is going to really, really help them ramp up and to become, able to make mass scaling. All right. So then we move on to low voltage systems. Again, just going to kind of drive through this relatively quickly. This was Pete Bannon and David Lau who talked about this. This is the original 2012 Model S. And oh my goodness, it just makes my heart hurt just looking at this thing. So, this is the crazy kind of thing that most, not just Tesla, but most manufacturers had to deal with. And what they're doing is they're moving towards the Model 3, which is a much, much more clean design. And they're looking at, designing their own controllers, and eventually, but past the Cybertruck, the next gen vehicle is going to be 100% their own design. And you can also see that they went to like electronic fuses and things. So there's just a huge amount of things that they did in the low voltage system to really, really help out. They also, I'm sad that I don't have this in mind, but they went from lead acid batteries to lithium batteries for the low voltage system. And they are going to move to 48 volts, which I don't think is here. Nope, not there. But you can see they've reduced the cost of the Model 3 and Y center display and increased the brightness. So the deal is always reduce the cost, increase the efficiency, give the customer a better product, which is a really, really hard combination of things to do at once. And then you can see the future. Yeah, here we go. 48 volts right there. So they're moving to 48 volts, which has a massive number of benefits associated with it. And in addition to that, they are going to be moving. So it's a little difficult to tell from this. And let me see if I can find this. Yeah. So in the Cybertruck, instead of having one central unit that everything plugs into, they're going to have a bunch of local units that are going to be connected via Ethernet cable, just standard Ethernet cable. And what that means is, remember, if we go back to that building things and components, you can build one part of the truck and that part can communicate with itself and it can test itself out because it has local controllers and things like that in it. And then when you plug it in, you just plug an Ethernet cable together and it goes into the master unit, which then can go like, hey, you doing okay? Everything good? And it can check it out. So this is going to allow a much more efficient parallelized design as far as I understand it. Again, this is what I understand from the presentation, but also it will allow it to be extremely flexible because you're not looking at massive CAN bus cables and stuff like that going everywhere. You're just looking at standard Ethernet to go all over the place. So really, really cool stuff. So super easy to update. Independent, you can build each part independently and not have to plug them together to test it. All of that stuff is amazing. All right. Then we get to the future of low voltage. So next gen vehicle, blah, blah, blah. So I wish they would show that. That's sad that they didn't show that. And then we get to some fleet data stuff. So we've seen this before. This is real world collisions where they can actually model this stuff out because they have so much fleet data. It allows for people to 123 million miles driven per day on the Tesla fleet. Wow. And 1.9 million charging sessions every day as well. So they have not just driving miles, but also charging sessions. They can see what the customers are doing. They were very careful to say anonymized data because I'm sure that they don't want people thinking that they're spying on them. So it's all anonymized. But this fleet data allows them to very rapidly understand what is needed from the customer space. We also have vehicle software as an integral part of the assembly line. This was very cool to talk about. And that's a different thing that we've talked about, not just in the car, but also in the assembly line itself. And of course, we've got, Tesla profiles, shared key. There's a whole bunch of new stuff that has come out, which is really, really cool. Let me see, ride comfort. Oh yeah. So one of the things that they've been able to do with the fleet data is actually update. Let me see if there's a slide for this. Oh, nope, we're into autonomy. So anyway, they actually have used the fleet data to allow the Model S and Model X to automatically adjust suspension when it's coming up to a rough section of road that it knows is going to be rough. And that's very cool. They were able to utilize fleet data in order to know what sections of roads are rough, which directions, how much they should increase or decrease the suspension, the pneumatic suspension and stuff like that. So anyway, that was just an example they gave and it's very, very cool. So, okay. And again, sub-assembly testing. Okay, autonomous vehicles. So I'm going to go through this relatively quickly because Ashok just more or less talked about what we already saw at AI Day. So you can see, self-driving is an important part of a sustainable future because you're utilizing cars more efficiently if the car is driving itself and the human being doesn't really necessarily even have to own the car. They can just use it and then it can be used all day long as opposed to just a few % of the time. So you can see some of the stuff that we saw in AI Day. And if you want to check out, I have a whole playlist on this. So go and check that out if you want to get more information about that. And again, we've got auto solving complex planning problems, and it goes from 10 milliseconds per individual action to 50 milliseconds to be able to do the complete thing, which means it can be operated in real time, which is pretty amazing. Then we get to automated labeling, which is also important. So not just, all the fleet data and stuff, but you have to be able to label that data so you know what's going on. So you've got automated labeling by multi-trip reconstruction, which allows you to build something like this from the fleet data, which is just amazing. And then you can go from there to simulations. So you can actually reconstruct this entire thing in a realistic sort of manner and then create whatever you want. Bad weather, people driving like maniacs, people walking out into streets, stuff like that. So you can utilize the real world data to create a simulation and then utilize that simulation to train the vehicle on a bunch of cases where you probably don't want real world data. You don't want people running out right in front of the car to test it. It's better to do that in the virtual world. So yeah, so we have a whole bunch of things. And then of course we have the thing that we saw at AI Day 2, which was that this was a parked car, not a car driving into it. And the important part of this is that the more data you get, the better the vehicle movement accuracy is, approaching 100%, which is great. All right, and let's see. Oops, I skipped ahead a few frames here. Then, of course, we get the data engine. So like I said, we're going through stuff that we've seen before. We get to the compute clusters. You need gigantic compute clusters. So basically, you need scalable FSD as AI team plus data plus compute. So that's basically where we're at. And then Elon came out in a very, very bizarre little sort of outtake, more or less. He just walked out and talked about Optimus, and they showed this really cool video of Optimus doing things, a bunch of Optimi, which was almost honestly slightly creepy because it was like a bunch of them walking around and doing stuff together, and they were all identical, more or less. So it was very, very cool. But what we saw them doing here was manipulating. So you can see like just random pieces of Optimus lying around and stuff like that. But it was picking up parts, and then we saw it like doing things like this. So you can see it's actually utilizing a tool, I guess building this one over here. It's like doing some medicine on this one, but it's utilizing some sort of a drill sort of tool. It also had another hand drill that it picked up and used. I don't think I screen grabbed that, but you can see that over in the corner here that there was this tool that it used, but it could pick it up and it could use it. And then it also had, back in this corner back here, there was a cloth, a black cloth over this picture frame, and it grabbed the cloth and pulled it off and pulled it off of the frame. And I have a feeling that went over everybody's head, but that blew my mind. Flexible, like soft objects are incredibly difficult for robots to deal with, because they're not, you know, rigid objects. Like if you pick up a glass like this, it's like, okay, it's a rigid object, it's not changing shape. If you try to pick up cloth or something, that's a whole different ball game. So it was doing amazing stuff. This was the part of the presentation that I was the most excited about, even though it was just a total random outtake. Elon's just like, yeah, here's some Optimus stuff, and he's walking around in the lab. This was amazing. I have a feeling that Scott and I are going to analyze this little video segment frame by frame. So hi, Scott, in advance. I'm sure we will talk through this thing eventually, but super, super interesting stuff. Anyway, so then we get up to, oh yeah, so that's all I was able to grab. It happened very, very quickly. It was just kind of crazy. So then we moved on to the charging experience, which you don't think about that much, but it's actually pretty amazing. Oh, before I even go on there, sorry, there is some other stuff I wanted to talk about. Again, Elon said custom actuators. It's designed to be manufactured. Again, stuff that we've already heard about at AI Day 2. Very little off-the-shelf parts. None are useful for humanoid robots. Again, we heard that at AI Day 2. But here's the interesting part, is that the product to market this at scale is useful to be faster than everyone else. Blah, sorry. I read that completely bad. In other words, they think that they can get this product to market faster than everyone else. There we go. That's what I meant to say. So he didn't put a timeline on this, but said that he thought that nobody else could do this. And I think at mass scale, there's no competition. There's just nobody else doing this at mass scale. He also said that the ratio of robots, Optimuses, to humans could be larger than 1 eventually. So if we have 8 billion people or so on the planet, we could be looking at more than 8 billion of these robots on the planet. So if you want your mind blown, just try to wrap your head around that we could have, you know, for every single human being, there could be more than one of these robots on the planet. And that will change the nature of life. They will become our companions and everything at that point, right? Probably babysitters, all sorts of other things, our butlers. I mean, you name it, they'll be out there. It'll raise an interesting ethical thing, just like with Star Wars, whether they have agency and rights to themselves. But anyway, that's their vision, is to have a greater than 1-to-1 robot to human being ratio on the planet eventually. So yeah. So anyway, okay, then we get onto charging with Rebecca Tanucci, I believe was her name. And we're looking at just some crazy statistics. 9 terawatt hours of charging. They take a holistic charging approach, which in other words, they think about the home, the apartment, the superchargers, all of that. But basically last year they did 9 terawatt hours of charging. 50% of that was on AC power at home, like many of us do. So just amazing. They have 40,000 superchargers, not just like destination chargers, but superchargers. So these are just incredible numbers. They have spent 10 years of building infrastructure. So again, you can look at the costs. Again, they're always all about reduce the cost, improve the experience, reduce the cost, improve the experience, all of that kind of stuff. And you can again see that they've done a 40% improvement in per kilowatt hour cost by utilizing each of their charging stations more efficiently. And the really interesting part about that is that she said that what they're doing is they're using the trip planner. So obviously we already know about this. It routes you to less utilized stations so that you'll get a better charging experience. But now what she was saying is they're going to start rolling out the ability to see where other cars that will be utilizing those superchargers are coming from. So one of the things you do is if you put in a supercharger as a destination, that car can then communicate back to the fleet and it can say like, I'm heading to this supercharger and I'm going to be there in 10 minutes. And if it looks around and there's like 20 other cars that are all going to be there at the same time, the next car that says, I want to get to a supercharger is going to go like, no, don't go to this one, go to this one, right? So it can utilize sort of like look into the future and kind of see where this is going to come from. So this is just an amazing thing, right? They've improved the cost per kilowatt hour while at the same time improving our experience of it. And that's kind of a remarkable ability to do that, right? It seems like you either get one or the other. You either like do like the airplane thing where you pack as many people on the airplane as possible, but then the experience, the user experience goes way down and we all hate our lives. Or you have luxury, Learjets that fly around with just a couple people on them, but they're extremely expensive. So in order to do both of these things at the same time is just amazing kind of stuff. And notice that they've reduced this down to 12 cents per kilowatt hour costs to them. So this starts to become a relatively profitable entity if they're doing that and they're charging like double that amount to the user for charging themselves up. So pretty amazing. So yeah, so she said it's like the air traffic control for charging. So anyway, and also it's become faster. So, so the charging experience has gotten faster. This is the trip planner, powers efficient trips and quicker, 30% quicker charge times. So you can see over time, it has actually gone down. It's really wild how it goes in these kind of cyclical sort of things. But so pretty amazing. And just yesterday in the United States, they got the Magic Dock working. And that's going to be a huge thing too, because that is going to change the way that other people can charge as well. I just saw something, oh gosh, I can't remember, Tesla Raj. So anyway, he did a video that was really cool showing a Rivian charging up at one of the Tesla superchargers with the Magic Dock, and it was very awesome and it worked amazingly. It wasn't even difficult. It was like super cool. So just incredible kind of stuff. And then this is interesting too. This is something that I hadn't really thought about, but they're looking at changing our behavior. In other words, when do we get the most renewable energy? Generally, it's in the daytime when you have a lot of sun. So the deal is going to be that they're going to start putting AC chargers around in cities and other places where people park. And again, they have the fleet data. They can know where your Tesla parks, so they can know pretty much exactly where people are parking all the time. And for those places where you're just sitting there during the day, that what you'd be able to do is just drive up to a parking place, plug in your car, and it would charge while there was sunlight. So it's the most efficient way of charging possible. And, not super fast charging, but just low rate charging so that while you're at work all day or while you're at the grocery store or whatever it is, the car just charges up. So this is just amazing, super cool stuff. And then of course, don't forget to do cool things like create this sort of thing where the charging is. So yeah, pretty amazing. And apparently the 4th generation superchargers are just starting to come out as well. I guess Europe, the EU first. So people in the EU, look out for the 4th generation charging things. They will have longer cables, which is going to be great. It is a challenge even with a Tesla to get that far back into these things, sometimes to get the cable to connect. And with a lot of other cars, like it could become very difficult to angle them in so that they're able to be charged. So these are all amazing things. So, yep. All right, then we move to supply chain. I'm going to jump through this really fast. It was Karn and Roshan, I believe, are the two people who presented this, but a lot of stuff about supply chain. And honestly, you should watch the video because it's just mind blowing what these people did during the chip shortage, the pandemic, all of that kind of stuff. What they did was incredible. I think it's worth pausing on this slide though. Too much talking. For I believe this is just yeah, this is hardware 3 just from looking at it. But this board has 7,000 components on it. And one component is being attached to one of these things every 1.4 milliseconds. And by automating the procedure, they were able to reduce the labor and also increase or decrease the defects, I guess would be the way to put it, by 95%. So we're looking at just incredible stuff. This is just one part. There's 7,000 items in this one part. So this is the kind of nutty stuff that they do. They moved 16 million pallets and racks last year, 1 billion electronic components shipped each week, not per year, per week, 685 service centers, 45 countries that they're dealing with. So these are just ridiculous numbers. And again, scaling against the odds, you can see that while all of this stuff was going on and everyone else was retrenching and not making progress and increasing sales, Tesla was doing that. They were eating everybody else's lunches. And then, of course, we get semiconductor industry. So I guess people are concerned that the semiconductor industry will not be able to sustain what they're trying to do. But they say that what they're doing is they're using 0.5% of the global amount of semiconductor wafers. Currently, it's not very much. And even into the future, without having to project out like improvements in what they're doing and stuff like that, they would still only be using less than 5%. So it's getting up to a significant amount, but even with 20 million cars per year, it's still going to be a very small amount. So the industry can sustain this for sure. Then we get into heat pumps. So, you know, this sort of mess turned into heat pumps. We get to next generation thermal architecture, 100 plus subcomponents that they had tried to, this is also going to make Scott happy. They had tried to build this with manual stuff. Then they tried to automate it. And what they figured out was that they could simulate this. So this lower left-hand quadrant down here is actually a simulation. It's a beautiful simulation. And then they were able to replicate that in the real world and have huge, I mean, look at this, 99% reduction in labor. That's pretty huge. 99.995% of the heat pumps received at Tesla factories are of adequate quality, right? And then 7 seconds between each heat pump rolling off the line. So these are just incredible numbers. So I hate to skip over this stuff, but it was just such a long presentation. But the people working on logistics and supply chain are incredible. That's all I got to say. And then, of course, you know, doing more with less, that's the theme, that's the name of the game. Max efficiency, doing more with less, scale to mass scale. And then, of course, building factories, super high volume factories. And this is actually Tom Zhu that talked about a lot of this, and he is famously from Tesla Shanghai, but he talked through a lot of what was going on. Whoops, that was not necessary, including things like the Model Y output, and how the labor hours were going down and the output is going up. And this was when Shanghai was shut down. That's what he noted was what that bump is. You see that in Fremont as well, just not quite as exaggerated of a graph. So again, simplify it, delete parts and processes, in-house construction team to build the factory. I did not know that. They have a lot of their own in-house people that actually build the factories themselves. So that's pretty impressive stuff. More modular design. 4 millionth Tesla was built today. He said, in fact, in the Texas, as the people were walking around for Investor Day, they might have seen one of the vehicles, the 4 millionth vehicle rolling off the line today. So that's pretty amazing. And it only took them 7 months to build the last million vehicles. So this is also incredible. So they're scaling and scaling and scaling at such an incredible rate. So their design process, question, delete, simplify, accelerate, automate. So don't put those things out of order. Don't try to accelerate or automate before you've figured out the other stuff first. So that's the important part with that. Yeah, and then 1 car per 45 seconds right now, which is just ridiculous. And 90% uptime in the factory, which is also crazy. The next factory, they're not going to say. They just said they need more factories. That's unfortunate. I hope it's in Mexico because I gave myself a pat on the back already. So if it turns out it's not, I'll feel really stupid. But anyway, they did talk. He talked a lot about how they unify the ideas across the factories and they take ideas from the multiple factories and they use them to improve the other factories, which of course is crucially important. So, yep, strengthen loop between manufacturing and service so they can do a better job with both of those. Getting towards the end here, folks. Thank you. And then we move on to batteries, and producing battery cells is much, much better. the let's see, no spoon powder to foil. So they've got the factory process working really well for the 4680. Finally, it's taken them a long time, but you can see that this is the sort of a graphic representation of the parts and processes, and also the just like the amount of stuff that's needed to build these things. And you can see that going from 2170 to the Fremont 4680 is a huge jump down. And then you go from the 4680 from Texas into the one that's going to be built in, I think it's Lathrop, is that right? I have to check that. Nevada, sorry, the one that's in Nevada. But you can see how the parts and everything and the processes go down. So it's getting to be more and more efficient as they go. And of course, you know, they want to get 50 gigawatt hours per year in Corpus Christi lithium refining. By the way, they are building a factory in Corpus Christi to do refining. So that I don't know if that was something that was known before or not. That was a surprise to me. So anyway, maybe people knew about it, but anyway. And then he gets on to talking about, oh, and this was the one in Hawaii that we flew over. We have a helicopter ride that we actually flew over, I believe, this particular mega pack installation with the solar panels. So cool. And then of course, growth is accelerating. So we're seeing even more stuff happening here, which is that we're getting to these mega packs. Apparently the mega pack XL is as big as you can transport legally. So that's as big as the mega packs are ever going to get, because you can't transport them otherwise. But this is also really interesting. Not just a big box of batteries. Everything is integrated, including the wiring and stuff is all inside the box, so you don't have to dig underground. You just have to hook it up to the power source. And it works with just about any power source. And it has a lot of high power components that are actually constantly balancing the grid. And what was it called? Oh yeah, he called it the product that retires fossil fuels. This particular product, which I thought was great. Where is that? I'm pretty sure. There it is. Retiring fossil fuel power plants with software. So that's really, really cool. I think that's kind of awesome. And they've reduced their installation of these things by 4x and the labor by 3x, 3 times for every one of these things. And of course, it's available to individuals in the power walls, not just grid scale companies. I'm trying to find where is it? There's this thing where they essentially what they say is that they have electronically, they're balancing, they're smoothing out the grid so that you don't get oscillations. He had synthetic inertia. That was the word. I was trying to look for that as we were going. So effectively, it's like if you imagine if you have a big flywheel that you're spinning, it has its own momentum. It has a mechanical momentum. And what they've done is create an electronic one so that it smooths out the power grid so you don't get spikes and oscillations and stuff. So it's actually good for the power grid to have these things on it because it helps smooth it out. So super, super interesting stuff. But anyway, build it fast, deploy it fast, make it efficient, all of that kind of stuff. Again, the theme of the day is all about that. And of course, you know, from the Roadster to all of these batteries they're creating, Tesla is energy, which is really, really cool. That's a great way to think about it. And yep, and there we go, back to that one again. And then build your mega factories faster, unlock the full value of distributed energy and storage, like in Texas. Here you can see that when you're utilizing this, you can actually save $61 a month. This is based on 5,000 Australian customers in 2022, which is just amazing. So I wish we didn't have an electric monopoly here in Georgia, but we do. So I won't be able to take part in this anytime soon, but for those who can, this is really, really awesome that you'll be able to do that. So, yeah, okay. So then we went on to ESG, or not ESG. Sorry, this is the electric rollout. There's more of this stuff. Yeah, more of that, more of that. And there's the beginning. Sorry. There we go. Here we go. So it's not ESG, but it sort of is ESG. But anyway, we went on the sort of Tesla impact, and you can see that there's a huge number of new employees. The person who talked about this was Brandon and Lori Shelby who talked about this. So anyway, just want to identify those folks. So hi there. Anyway, so you can see that Tesla again was ranked number 2, SpaceX number 1 last year for, you know, place that engineers want to go work. They had, I believe, 3 million applications last year, something insane like that. You can also see that as they've increased the employee engagement by allowing people to ask questions and do comments, that their accident rate has gone down drastically, which is also excellent. Lori says very specifically that they don't just tick boxes, they try to do things that actually make a difference. So again, it's sort of ESG, but it's also sort of not. So anyway, and then, you know, sustainability for employees and not just for their products as well. So yeah, and then this is also very cool. Their products generate more energy than the products and factories consume. So that means that the generation of power is actually larger than the amount of power that all these things consume. And that is an impressive figure. All right. And then of course, emitting less emissions than gas, that's pretty obvious. Reducing cost of existing products, which is good. And, oh, I'm sorry. We've actually moved into financials now. Sorry. So this is back to Zach Kirkhorn talking here. So we've got a 30% reduction in the cost per car over from 2018 to 2022 with the Model 3. And that's just with the model without even an official refresh or anything. You can see how it's done. It's not just done with one part. It's done with many different things, efficiencies, improved products, volume growth, et cetera, et cetera. And that the new next-gen vehicle, even though they won't introduce it today, is going to have a 50% reduction off the cost of the current volume product. So that's where they're getting all of these parts, which is very, very impressive stuff. This is also really cool. This is a total cost of ownership per mile over 5 years. The Toyota Corolla costs a significant amount more than the Model 3 base version. And then the next gen vehicle is going to be significantly less than that. So, you know, if you're saving a little bit of money right now on total cost of ownership over a Corolla, and a Corolla is like a $20,000 car. So it's a very cheap car, sticker price wise, and you're saving a lot of money just getting a Model 3 over that. Total cost of ownership, and the next gen vehicle is going to be significantly cheaper than that. So this is actually really important stuff. Again, operating expenses as a percent of revenue, and you can see how operating expenses have just gone down and down and down. Just amazing stuff. Again, I don't know how they do it. It's like the whole Tesla group is just run by a bunch of wizards in their own individual areas. And then you get industry leading selling, general, and administrative expenses per car. So now this does take the dealership into account, so it's a little bit of a non-apples to apples, but it makes a difference. Zach said this translates into about several, I think $3,000 to $4,000 per vehicle, something like that. So it's just amazing that they have this lower, 60 to 70% lower selling, general, and administrative cost per vehicle than traditional auto does. It just makes it impossible for them to compete with Tesla. That's basically what happens. So again, it's all about everything. It's not any individual thing. It's all about a lot of these things, a bunch of efficiency improvements that we can see. And here we get our pace and scale to improve over time. The total investment that they have done up to now is $28 billion. The terrifying thing is, in order to get to $20 million of annual vehicle production, they're looking at $150 to $175 billion worth of, you know, investment into it. So it's a big investment. They need to keep that. And that leads to this slide, which is that we will probably never see buybacks or dividends because they're going to make sure that they have the best daily operations they possibly can, save money on that so they can do growth, R&D. Then they're going to look for opportunistic things that they can do. And then finally, whatever they can do with excess. So don't expect dividends or stock buyback anytime soon from Tesla. That would be my takeaway from that. And then finally, of course, we get innovation-driven cost and efficiency, improved affordability, reinvest to achieve unprecedented scale, and accelerate the world's transition to sustainable energy. Whew, there we go. Let's see, how long was that? Oh, 1 hour. I was going to try to do it in a half an hour. So there you go. It's still 1/3 the length of the original presentation. So anyway, I'm going to let you go now. I hope you enjoyed this. If you did enjoy this, please do like it so other people can find it, because it was a lot of time put into building this thing out and watching the presentation. It was a lot of fun. Anyway, I hope everybody has a lovely day. Let me know what you think is your favorite part of this. I think personally mine was actually the heat pump for houses and stuff, and Optimus. Those were my two favorites. But let me know what your favorites are in the comments. And in the meantime, I will see everybody in the next video. Bye-bye.